Welcome everyone. Thanks for coming. My name is Mayank Mehta. I work for Capital One, and today we're going to talk about a practical guide to understand reactive streams. So let's get started. So what's the prerequisite for this talk? All you need is curiosity to know how we can use RxJava in clean architecture. That's the agenda for today. We'll try to go through the basics and eventually end up discussing how we use in our architecture. By no means I'm saying this is the only pattern that should be used by everyone. It's just that what has worked for us so far, and we're constantly looking at ways of improvising it. So what we really use is an MVVM pattern along with RxJava, and what it has helped us is write modular code that has made it more testable. Concurrency operations are extremely easy now, and we'll look through some examples and we'll discuss how that works using RxJava. Better code, because the functional programming, there's less states, so less issues. And happy developers. We're able to do write code faster, less bugs, and ship products much sooner. So terminology, right? Like RxJava is a little complicated, and it needs a real steep learning curve. So we'll talk about a few terminologies, and so that we are on the same page and makes it easier for us to be on the same page throughout the presentation. So what are sources? Sources are something that generates data. RxJava provides multiple sources, multiple ways to generate data. In today's talk, we won't be talking about Flowable just because time constraint, and it's already a long presentation. So we'll skip Flowable, we'll discuss all the others. So what's an observable? An observable is a source which would generate items from 0 to n, and eventually when it's done generating items, it'll either finish, and if it errors out, it'll throw an error, and that's a terminal event. This is just a marble diagram that you'll see throughout the presentation. What we really represent here is our source is generating 4 different values, and the vertical small line is notifying that it's completed. So simple. So now we know what actually a source is, right? Now, how do you get the data from the source? How do you listen to that source? And the source being an observable here, you would subscribe with an observer. That's an interface, one of the interfaces, and it has 4 different callbacks. The first one being an onSubscribe, which gives you back a disposable. At the end of the presentation, we'll really talk in detail as what disposable is and how do you use. But anytime when you do a subscription, the first callback that you should be getting back is the onSubscribe, followed by an onNext. So in the previous slide, we saw a couple of items getting emitted from the source. Every single item would be pushed down through onNext to your observer. If for any reason your source errors out or something were to go wrong, that error would get piped through onError, and you'll get a throwable. An onComplete is just the source telling you that I'm done emitting data. Go ahead with whatever you want to do now. That's just a completion event. OnError and onComplete are generally termed as a terminate event where your source is completely done. Other way of subscribing to an observable is through a consumer interface. It's pretty lightweight compared to the previous one, where all you get is an accept callback. Now let's talk about single. Single is something which would emit a single item or error out. What we have done in our application is, for the most part, all our API responses are modeled as single, because in true sense, when you look at those APIs, right, you make an API call to fetch the data or update something. It's not a constant stream of information, right? You get the data or you post and you're done with it. So for most part, that's what our APIs are modeled as. Maybe is something where you would either emit an item, or you would complete without emitting an item, or you would just error out. We generally would use this to use for sources which are sort of optional, where the chances of items not being present is possible. And completable are the simplest one, where there is no emission as such. Either it's going to complete without an error, or it's going to error out. What we use completable are generally for fire and forget sort of a request, wherein you're making an API call, you really don't care what the response is in terms of the response body. All you care is this, was this a successful or did it error out? So we looked at 4 different sources of data, right? And that's good. Now, what do you really want to do with the sources? You would prefer to do some sort of transformations. RxJava would provide you multiple different operators to do some sort of a transformation, some sort of filtering that you could apply to it. We're going to look at a few of them, but there are hundreds out there. And how do you really use these operators? If I could say, or in a very higher level, operators are used as we would have seen in a builder pattern, where you chain the different methods, except when you apply operators to your sources, the order really matters. So let's look at the first operator. It's a merge operator. As the name goes, it combines output of multiple different observable streams. So this is a marble diagram. 2 rows up top are your sources. Say the first source emitted an item 1. Your merge operator is just going to give that item as an output. Source 2 emits an item 4. It's going to put that out. And that's how it works. Basically, given 2 different sources, it's going to merge those output and give it out. As you can look here, the output are interleaved. And what I really mean is 1 and 4 are from completely different sources, and they come after each other. So keep that in mind. Concat operator, as the name goes, it's going to concat the output of multiple observables one after the other. And how it really works is, say you put 2 observable sources through a concat operator. It's going to subscribe to the first observable and let it finish, and then it's going to subscribe to the second one. And as a result, the output are not interleaved. Let's look at an example of that. So that's our first source who is emitting item 1, 2, and 3. So that was the first source that your concat operator subscribed to. It let it finish, and then it subscribed to the second observable, which emitted 4 and 5, and then eventually it put that out. So if you're going to do a parallel operator, if you want tasks to be done in parallel, concat is not really what you would need, because it could add potential delay to the task that you want to do. So those are 2 different difference between them. Merge, output is interleaved. Concat, the output is not interleaved. Let's look at flat map. It's one of the operators which were more complex for me to understand. And honestly, this is the operator that you would use the most while working with RxJava. So what really happens in flat map operator is, say you have an observable which emits a source of data. The flat map lets you apply a function on every single item emitted by the source. And the contract here is the function that you apply to every single item needs to return an observable. Eventually, those emissions of the functions that you apply to the item are flattened out, and emission may interleave. So flat map inside of it uses a merge operator. That's why the output could interleave. So let's look at an example here. So that's our source which is emitting an item 1, and say you're making an API call. And because of the flat map, it lets you apply a function to it. Say you made an API call making a request passing 1 to it. So you created a new observable. Source emits another item. So flat map is going to create another observable for it. So now we have 2 different observables running in parallel. And for flat map, it doesn't matter who came first. Whichever task gets finished will be put as the output. So say second task or second source observable finished, and that was emitted, and the sequence continues. So that's flat map for you. So if you look here, there's a search box here, right? And one of the issues that you would find with the search is user would enter something and hit a search button, right? If they change their mind, they enter something else and hit the search again. So what could happen is you could have multiple API requests in parallel, and you would not want the older request to still showcase the data on the UI. You would prefer to show only the data from the latest search that user did. And Rx has a very simple operator for that called switch map. And what switch map really does is, it's still like a flat map where it lets you provide a function to every single item from the source, but except it mirrors only the latest item. And what it really means is, Say user hit 1 and hit the search button, you applied a function, made an API call, meanwhile user entered 2, hit a search, and now the request is in progress. What switch map really does is it disconnects from the first source and just mirrors the second one. And as a result, your UI is always showcasing the latest search. So this is how simply you can achieve so complicated task otherwise. So let's look at another one, concat map. It's like a flat map, but if we remember the concat operator from the beginning, where the output is not interleaved, still gets carried forward to here as well, where you apply a function to every single source, but the output is definitely in sequence. Let's look at another problem. In our application, we fetch multiple credit cards, debit cards for the user on the home screen. At the same time, we go ahead and get multiple gift cards for the user. The requirement here was we have to wait for all the APIs to finish and then apply transformation to it. If you were to do this in a non-Rx way, you could have used the concurrency package, apply some thread locks, wait for the threads to finish. So it's not entirely difficult, right? But with Rx, there's a very simple operator called zip, wherein what zip operator really does, it lets you combine multiple sources, output emission of multiple sources into one. It waits for an output from every single sources. So that way you can easily wait for multiple APIs to finish and then eventually apply a transformation to it. So let's look at an example for that. Say your source 1 emitted an item 1. Now the zip operator is going to wait for source 2 to emit an item. Now whenever a source 2 emits an item A, your zip operator lets you apply a function or lets you apply a transformation on it, and the output of that would be 1A. Now say source 2 emitted an item B, which was much faster than the source from the first source. It's going to wait until it gets the item from the source 1. As soon as it gets that, it lets you apply a transformation. So zip operator works simply like a zipper, where it's going to wait an input from both the ends and then lets you provide transformation. So let's take a step back and see how easy it is to use this operator and get the work done. Let's look at another problem. So again, the search box is here. What generally users do, right? They'll apply some search criteria, and you would not want to initiate the request as soon as they have written something, right? You would prefer to wait for a couple of milliseconds before you initiate the API call, just to make sure that, okay, user has done typing. There is an operator for that called debounce. And what debounce really does is it lets you apply a time span on the search or on your source and tells that if the time has passed and a source has not emitted anything, I'm going to let this item go away. So say user typed 1 as a search criteria and user didn't type something else until another 500 milliseconds. A debounce operator looks at that and says, okay, no more search for 500 milliseconds. That's a valid search. I'm going to pass through it. Now say, for example, user types 2, 3, and 4. 2 and 3 are invalid, right? Like we still need to wait for the search to finish, or like for the 500 milliseconds to finish. And that's where the 4 comes into picture. After 4, there is really no more search getting typed and 500 milliseconds has passed. And that's good enough. We can make that search now. So we looked at few operators, and all of those operators are going to come along well in the slides after this, where we look at the examples how we use inside our apps. One of the other very important topic in Rx are subjects. What are subjects, right? When I look at subjects, I think they are more like walkie-talkie, and what they really mean is they can broadcast to many different receivers. They can broadcast when nobody else is listening, and they can listen from many different participants in the same channel. So that's what subjects really are. So if you look at this, they are an observable as well as they are an observer. And how is that possible, right? So that's the code. Subjects basically extends observable and eventually implements observer, and that's how they get both the roles of being an observable and an observer. Because it's an observer, you get all those 4 callback methods that we saw in the beginning. But if you were to look in more details, right, it gives you a capability of doing an on error and on complete. And they are the terminal event. Say in your application you're creating a subject and subscribing to it, right? You are giving somebody else the opportunity to call an on error or an on complete on that stream, and eventually that stream is of no use. And that's not always what you need, right? Subjects are good, but this is the gotcha that you should keep in mind. Not all your requirements would end up requiring an on error and on complete to be called. So there's a library called RxRelay from Jake Wharton, and which essentially solves that issue. It's still an observable, but instead of it being an observer, it implements a consumer. And because of the consumer, it only has one interface method, that is accept. There is no longer an on error or an on complete. So you're pretty sure that nobody else in your application can accidentally call a terminal event on this. So we don't use subjects as is, but we use RxRelay in our app heavily. So there are 4 different kinds of RxRelay. What we use is published relay and behavior relay, and let's look at them in detail. What's in published relay? Published relay is something which emits item only after somebody else has subscribed to it. We generally use this for a login and logout event, where multiple different components in our app, whenever they come alive in the flow, they would go ahead and subscribe to this published relay and eventually listen for the login and logout events. So again, let's look at an example of this. Say your source emitted an item 0, but nobody else is subscribing to the published relay yet, so it's not going to emit anything just as of yet. Whenever a first observer subscribes to it, it gets the first item. See this, it never got 0 because it was emitted by the source even before this observer subscribed to it. When observer 2 subscribes to this, it gets the future events, and it continues. So that's published relay for you. It doesn't remember items that were emitted before the subscription. Let's talk about behavior relay. Behavior relay are something which is a step advanced to what published relay are, wherein it remembers one last item that was emitted even before the subscription happens. Let's take an example. So say your source emitted an item 0, your observer subscribes after that, but because it's a behavior relay, it's going to emit 0, and that's its property. We use this heavily while communicating between our presenters and the view. We'll look it into details in a couple of slides from now. But the idea here is you always get the last item when you subscribe. Now say our observer 2 comes and subscribes. It would not get item 0, but instead it'll get item 1 from the source, and the sequence continues. Good, so we looked at subjects, we looked at few operators, we looked at sources, right? Now let's see how we can apply that in our application. All of us would have legacy code which is non-Rx, right? How easy it is, or how is it possible to convert them into a reactive source? Say there are 2 different ways, right? There are 2 different sources of data for us. One is callback, one is actual function, and we'll look at an example how we can convert both of them into a reactive source. So this is an actual code from our application, which is a location service. Whenever you invoke this and ask for a location, you can provide a callback. Callback is standard interface. It gives you a success with a location if one exists, or it will fail with a failure. So how you can convert this into a reactive source is there's something called create operator in RxJava, where you can convert your non-Rx source into a reactive source. So we use this create operator. If you see, we are calling this create operator on single. Single, if we remember correctly, single was something that emits an item or errors out, and that's what we need, right? That's how it mimics to our callback behavior. So this is a callback that we implement inside this. We call the standard method on the class, which is get current location, and we supply the callback which we have initiated. Whenever the location task finishes, it calls this callback, and we use the emitter. Emitter here is what will pass on the value to the subscriber of this code, and we will call the emitter on success when there is actually a success, and we'll call an on error if something were to go wrong. So this is how, with few lines of code, your callbacks can be migrated to a reactive source. Now let's look at another example, right? Say you have some functions which does heavy computation. There's no callback here. How you can convert this into a reactive source? RxJava provides an operator called from callable. which basically defers the execution of this function until somebody subscribes to this. So whenever somebody subscribes, it goes ahead and executes the sum heavy computation method. It also does it also handles the checked exception. Like say some heavy computation were to error out for whatever reason, it's going to call the on error on the single and it will handle it for you. There's nothing else that you need to do. Anytime a new subscriber subscribes to this line of code, it's going to execute some heavy computation again. There is no sharing of observables between them. So good, so we looked at that. The next one is schedulers, right? Like I've mentioned a couple of times how concurrency is so easy using RxJava. RxJava provides multiple schedulers. I've listed few of them here. The key things to note here is computation is something which is thread bound, which is only the number of available processors on your device. But apart from that, IO and new thread schedulers are all unbound operators. So you should keep in mind when you use this kind of operators, you do not want to misuse them. But how do you use concurrency in your RxJava code, right? It provides you two different operators. One is called subscribe on, and other one is called observe on. Let's see how you can use that in your code base. This is simple application where you're using from callable, get method, and there is something called do on next and subscribe. If you look here, we are not specifying subscribe on or observe on. And as a result, there is no real threading that you are specifying Rx to do. So what happens is when you don't specify a threading operator, and any thread that calls the dot subscribe becomes the default thread for you. So say this code was running on your main activity, inside your main activity, or which is basically your main thread. Everything here would eventually run on the main thread because dot subscribe was called on the main thread. How do you use the subscribe on? Whenever I look at subscribe on, that's the one way of switching your threading from your main thread to the computation thread. That's one of the operators. So because you specified subscribe on, everything on this specific code would all work on the computation thread. But what if I want to do multiple different subscribes on? What if I want to switch between the computation thread and IO thread? That's not possible. If you look at the hierarchy of code at this level, you cannot provide multiple subscribe on. You can only provide one subscribe on. One which is high up on the top wins. So even though you have specified multiple subscribe on, it doesn't error out, but everything would still run on the computation thread. The IO thread has no impact on it. What is observe on, right? As we said, you cannot have multiple subscribe on, but what if you want to switch threads? And that's where the observe on operator comes into picture. When you specify an observe on, any code that runs after that operator will be on the thread that you have specified. So here, because the subscribe on, anything above it would be on that thread, which is computation. And because you had an observe on after subscribe on, everything beneath that would be on the main thread. So that's how you'll be able to switch between different schedulers and get the work done. However, you can have multiple observe on, and that's what we're trying to do here, right? We're initiating the main operation of from callable. Say get name here was really heavy computation. You want to do on a computation thread. Now we switch back to the IO thread, maybe make some network calls, and eventually when the response comes back, we want to update the UI on the main thread. And that's how we could use 3 different operators here and get the work done. Standard IO thread, and now this would be on the main thread. Good, so we looked at few basic operators that we could use, right? Now all this was precursor to how we use in our architecture. So discount feature is something that we released recently, wherein we are showcasing discounts as per users' purchase behavior. The only reason I'm showing this feature right now here is some of the code might be more contextual to this screen, just as an FYI. So how our architecture really looks like, right? On a really, really higher level, we try to look it into 5 different boxes. Then we divide it into 3 different tiers. We prefer our application to do a unidirectional data flow from left to right based on the events, and from right to left whenever the source has the data. we try to expose a reactive source through different tiers or through different layers. I'm just referencing observables here. It could be single based on the API that you're implementing. But the idea is every single layer would be exposing some sort of an observable that somebody higher up on the UI side could subscribe to. So let's look at our data layer, right? What's our data layer? It's a simple repository pattern, nothing fancy here. It holds the business logic of, okay, where should I be getting my data from? Should I be going to the database first, or should I go to the cloud? And that's all its duty is. It does nothing more than that. And our business use case was go to the cache store, right? Go to the database. If you have the data, fine, don't make the network call. If that doesn't exist, go ahead and make the network call. If you look here, we're using the concat operator, which we learned in the beginning, which basically subscribes to one observable at a time, right? So it's going to subscribe to the cache operator, but at the end, we have something called first or an error. What it is telling to RxJava is, if you find the data from the first observable, that's it. Do not go ahead and subscribe to the another observable. This is so easy now, right? Like one operator and that's it. It goes to the cache store. If it finds the data, fair enough. It's not going to subscribe to the cloud store. If it doesn't find the cache store data, it's going to make the cloud store request and get the data. Just 2 lines. So what our cloud store is, right? Cloud store is something simple which makes a networking call. Second, as soon as it gets the data, it updates the cache. So here our cloud store is making an API call, which is, as I said, we model most of our responses as singles. So which is mapping to a single with a nearby response. It has a filter is another operator which we haven't looked at yet, right? Filter, as the name goes, it lets you provide a predicate wherein what we are telling RxJava here is, if the nearby response has merchants which is not empty, then only you should proceed. Otherwise, you finish here. The map operator is just basic transformation, right? If you look the line above it, it is a nearby response, but the output of the map operator is a list of merchants. So map operator generally lets you provide some sort of a transformation to your data source. This is also something new that we haven't spoken about here. Do on success, how we'd like to term it as, is a side effect, wherein it doesn't really change the source of data, right? And what we mean here side effect is you got the data from your clouds, and now you should be updating your cache store, because for us, cache is the true place of where the data should exist. So we go ahead and update the cache store as a part of this response, and everything goes ahead after this. So let's look at the domain layer. What we really do here is every single business logic is broken down, and every single implementation of this interface does only one single business logic. We refer this as a single responsibility principle. Again, nothing new, has always existed for years now. But the idea is break down your business logic into multiple different use cases. And this gives you a flexibility of combining all these use cases again on a higher level if need arises. And yeah, that's just a generic interface that we use where you specify an input and output. So now this is the key here, right? Like, what's really a presentation layer for us? It has a view and a presenter, standard, nothing new. But we have something called view state. And view state, what really means is it is a true state of your UI. And we'll look at a few examples here. For us, that specific flow had 3 different view states. One is the loading view state. One is when we have list of items to show on the UI. One when there's some sort of error happens. So that's how we break down every single flow into multiple different view states. And this is just an example of using a seal class where we are specifying 3 different data classes for what our view state looks like, which is good, right? Now, how do our view and presenter talk to each other? It's again standard, where whenever a view is created, presenter's onCreate method is called, and this continues, and on attach and on detach. So our presenter is aware as what state of our view was, and so that it can do task accordingly. We spoke about publish relay, right? And so how do we use publish relay in our presenter? We expose publish relay as a source of input from the view. Say we expose a publish relay would take a form submission or some sort of a view state that the UI would trigger, and you'll pass it on to the publish relay. The catch here is we create the publish relay on the onCreate. We spoke about behavior relays. In the next slide, we'll look into more detail as how behavior relay help us solve a lot of complex issues. But we attach the behavior relay, or we attach to the behavior relay on attach of presenter. Equally, we should be disposing the right set of disposable based on what part of a presenter's lifecycle you are at. Anything that updates the UI, those should be disposed on an on-detach, and anything that you're done with the activity should be disposed on the on-destroy. So let's look at an example of how this publish relay and behavior relay work together. Say you attached the view, user did some action in the UI which initiated some sort of a flow. Your presenter goes out and makes the API call, right? And now what could go wrong? The user could do configuration change, or user could press the home button, and as a result, user could press the home button, and what could it really do is it will invoke an on-detach. So now your view is on-detach, right? But at this point, you would not be updating on the UI because your view is detached, and that's not the right way to do. So what we do is, whenever the data comes back and say the view is still detached, we create a view state, be it an error state or be where we have an actual data, and then we pass it on to the behavior relay. So behavior relay would hold on to the view state when the view is detached, and whenever the view gets attached again, the behavior relay will the presenter will subscribe to the behavior relay, and now it knows what's the last item it had, right? Like the behavior relay's property was, I'll remember the last item that was sent out even before the subscription happens. So on a non-detach, our behavior relay hold to the state of the UI when it was not attached, when it was detached. On a non-attach, it's going to subscribe again, remembers the last item, updates the UI state which was missed, and only thing is it makes sure that only the distinct view states are shown on the UI. So you're not showing, so that you don't show any flickering of the UI, right? Like say if your API is getting the same sort of a data, you don't want to update UI twice, which could cause a flicker. That's why we use a distinct operator, and we'll see in the next slides. But distinct operator makes sure that only thing that has changed can be given out as a part of the operator. So let's look at the presenters on create. What really happens here? Say fetch nearby coupons was a publish relay that was accepting the inputs. You apply a flat map, and what was flat map was it takes the input, lets you provide a function which returns an observable. So your flat map is basically executing a use case which is going to emit, say, a maybe of list of merchant wrapper. We are converting this maybe to an observable, and this is very important here, is why we are converting this maybe to an observable. Reason being, we are updating our UI with multiple view states, right? Like we would want to update our UI with the loading icon, and then eventually when the data comes, you would want to showcase the list view. So that's why we are converting our maybe operator to an observable on our presenter end. Map operator does simple transformation where it's converting the list of merchant wrapper to whatever it wants to do. On error return, this is the try catch of RxJava, wherein if anything were to go wrong in making the API calls through the use cases, it is going to boil down to the on error, and will catch the exception and eventually update the UI with the discount view state of an error. This is the start with that I spoke about. Like the only reason we were converting maybe to an observable so that we wanted to showcase some state in the beginning of the UI, right? So anytime the publish relay were to get an input and this piece inside the flat map were to get executed, the start with will get called for the first time. That is how we showcase the loading icon before making the API call, and then proceed with it. Observe on, we use this Android scheduler's main thread, which is a part of Rx Android package, which is basically letting us move on to the Android's main thread to update the UI. And this is standard subscribe that we looked before. Here we are just getting the view state as a part of on next and updating the behavior relay, right? And behavior relay is the one which I said holds on to the true view state. So what really happens inside the onAttach? As I said, onAttach, we subscribe to the behavior relay. We apply the distinct until change operator. So we're pretty sure that anything that comes out of the behavior relay is unique. We move on to the main thread, and then view is basically the interface that our views would implement, and we'll just call the render method on it. And that's how the presenter is able to update the view with the right state. Eventually, we add this to composite UI disposable. If you remember when I said that observer interface gives you back the disposable, and this is what it is used as, right? Like if you do not dispose your observable in a timely manner, you could leak memory. And the composite UI disposable are primary reason that we hold on to our behavior relays, because you do not want to update the UI when somebody is detached. And this is how we attach in the presenter. We'll add this to the UI disposable and eventually detach it inside or dispose it inside the onDetach. I've spoken so much about dispose, right? Like, so how do you really dispose something? There are two different ways of disposing the observable. One is through clear and one is through dispose. What clear really does is, clear will call the observable to dispose, the composite disposable to dispose all the observables that are assigned to it, but you can still add more observables to it in the future. And dispose, the only difference is once you dispose the composite disposable, you won't be able to add anything else to it. And that's the key difference. So you should be using clear and dispose based on inside the onDetach and on destroy method. Over the course of time, I've learned a lot from their blog posts and from their different talks at different conferences. I would encourage you to check their blogs out. Really good information. I guess that's it. That's all I had. If you have any questions, let me know.